Okay, we have here today an interesting integral suggested by Chris, and it has quite a lot going on with it. So we have the integral here of the cube root of x over the square root of x plus fourth root of x dx. Okay, this one was really interesting. Now, one thing I want to do to start with, I kind of want to just rewrite this with our fraction exponents. So we'll write it as x to the 1/3 plus x to the 1/2 plus x to the 1/4. The way I like to approach this, when we have two things in the denominator, we've got different exponents, so I'm going to factor one of these out. And when I factor it out, I bring that into the numerator, and then we get kind of a new exponent in the numerator. And then what I hope is after the factoring, we have a nice u substitution set up, and we can finish it off really quick. Now in this case, it might still work to factor it out and do that, but I don't think the u substitution is going to be that clean. So I think that's going to be some work that way. It might be fine, but I didn't really try it that way. What I decided to do first was try to get a common denominator between these exponents. So like, just for example, I write my 1/3 as 4/12. I wrote my 1/2 here as 6/12. And then 1/4, I can write this as 3/12. So now I can write all these exponents with a denominator of 12. So then from here, what I did, rather than factoring this, is I was just going to do my u substitution now. But what I'll do is make my u equal 1/12. So by doing this, we're going to have an integer exponent now for each of these terms. And I'll solve for x. So x is just going to be, taking the 12th power on both sides, x is going to be u to the 12th. And we find our dx is going to be just 12u to the 11th du. And then I'll go ahead and we'll make the substitution. So the numerator is going to become, this is going to become u to the 4th. We're going to have u to the 6th plus u cubed. And our dx, the 12 I'll bring out front. And then we're going to have a u to the 11th du. And then now we have our integer exponents, but now I'll do the factoring that I skipped earlier. So I'll factor out a u cubed here. So I can write this as u cubed plus 1. Then the numerator u to the 4th times u to the 11th, that's u to the 15th. But I'm going to factor a u cubed out, and we'll write this as u cubed times u to the 12th. And that's going to set up this cancellation. And at this point, this isn't looking too bad. We could do polynomial long division on that, but I almost always avoid it. So what I'm going to do instead, I'm going to subtract a 1 here to try to set this up. Don't want to change it, so we'll add a 1. And then let's just rewrite this. So I'll still have my 12 out front here. U to the 12th minus 1. I'm going to split this up as a difference of two squares. So first of all, I can write this as u to the 6 plus 1. And then we'll have u to the 6 minus 1. But in one step, I'm actually going to do difference of two squares again and write that as u cubed plus 1, u cubed minus 1. And then we're going to have a second integral with just this 1 right here, but I need to distribute the 12. So let's see, for the second one, I'm going to have 12, and this is just going to be du over u cubed plus 1. Now for this one, the u cubed plus 1 is going to cancel. So multiplying this together for the first integral, we're going to get u to the 9th, then we're going to have a minus u to the 6th. I'm kind of putting it in order. We're going to have plus u cubed and a minus 1 on the end. And then I'm just going to bring this stuff down. Okay, now from here, the beauty of this, that's all power rule right there. So what I'm going to do is just integrate that really quick. So this is going to be u to the 10th over 10, u to the 7th over 7, u to the 4th over 4. My 4 looks kind of like a u, right? I need to work on that. And then we're going to have a minus u here. And then I'm going to just distribute this 12 in while I can. So this is going to give me, I think, 6 over 5, u to the 10th minus 12 over 7, u to the 7th plus 12 over 4 is 3, u to the 4th, and then we're going to have a minus 12 u here. And then here we're going to have just plus 12, this du over u cubed plus 1. Okay, so we're getting closer, but now there's just one problem. This integral here, now I've done this one before. I have another video on this somewhere. And this one here is not too hard, but it actually takes a little work. So what I'm going to do is clean up the board. I'm just going to do this separately and work it out, and then we'll come back and plug in our answer right here. Okay, so quick detour, we're going to run through this integral and then we'll get back to our goal in a minute. So with du over u cubed plus 1, what I'm going to do is factor this thing. I can think of this as a sum of two cubes, and I can write this as u plus 1 times u squared minus u plus 1. So how am I going to handle this? This is going to be partial fractions. So what I'm going to do is write this fraction. We're just going to split it up down here, and I'm going to write it out. And then I'm going to, of course, break this into two fractions. So our first one, I create a constant a that we need to find. Because we have here a first degree polynomial, we just need a constant value here. And then for our second one, we'll have our u squared minus u plus 1. And then here we're going to have bx plus c. So then for our a value, what I can do is the cover-up method. I can take -1, plug it in here. That's going to make this 0. So what I'll do is cover that up, so we're not dividing by 0. Plug it in here, and you do this out, you're going to have 1 minus times minus is +1 plus 1. This is going to be a 3, and then this is going to be a 3 here, so we're going to have for a 1 over this 3. And then for our b and c value, what I'm going to do is just plug in some common values. Like I'm going to try first u equals 0 and plug it in here. If I do that, what's going to happen is we're going to have 1. This 0 plus 1 is going to give me a 1 here. Plugging 0 in here is going to be another 1. So on the left-hand side, we just have 1. Then plugging a 0 in here, we're going to have 1/3 over 1, or just 1/3. Plugging a 0 in here, that's going to cancel out the b. We're going to have c over 0 minus 0 plus 1, another 1. If I subtract a 1/3 on both sides, I'm going to find my c value is going to be just 2/3 here. And we'll just plug that in right here. Okay, so all we need now is we just need our b value. And we've used -1 for a, we used 0 here. So let's use 1. So I'm going to say, what happens when u equals 1? I'll plug a 1 in here. I get 1 over, this first piece is going to be a 2. 1 minus 1 is 0, plus 1. That's just going to give me a 1 here. So this left side is going to be just 1 over 2. Then we're going to have our a value, which now we know is 1/3. 1 plus 1, we're going to have 2 in the denominator here. Plus our b that we don't know times 1. Plus c, which we now know is 2/3. I plug a 1 in here, again, it's going to be 1 minus 1 is 0, plus 1. I think I'll just clean this up a little bit, so we're looking at 1/2. 1/3 divided by 2 is going to give me 1/6, and then we're going to have plus b plus 2 over 3. Now, if I multiply this through by 6, I'm going to end up with 3 on the left side. This is going to become a 1. We're going to have 6b, and this is going to be a 4. So solving for b, we're going to have 6b equals -2, or b equals -1/3. And so we'll just plug that in right here. And so that's it for the partial fractions. I'm just going to take this, we'll put it back into an integral, and we'll continue on. Now at this point, this first integral is looking really easy. That's nice. This one looks doable, but it's a little confusing with these coefficients. What I'm actually going to do is take this -1/3. Let's actually factor that out front. So I'm going to write this with a -1/3 in front, and then just adjusting this so that it works. This value here is going to become a -2. But now the way I want to handle this thing right here, I want to do this by substitution. We already used u, so let's call this a t. So I'm going to say my t is u squared minus u plus 1. If I take my derivative here, dt is going to become 2u minus 1 du. So I want to set this up in the numerator. What I'll do is I'll multiply by a 2 here. I don't want to change it, so we'll divide by 2 or multiply by a half out front. When I distribute this in, this is actually going to become 2u minus 4. We want 2u minus 1. So what I want to do is force this 2u minus 4 to match this right here. I'm going to do some cleanup. To make it work, I'm just going to write my 2u minus 4 as 2u minus 1 minus 3. And then what we'll do is we'll take this -3 and break it out into a separate integral. So when I separate this into another integral, the -3, I'm going to multiply by this -1/6 in front. This is going to give me a +1/2. And this integral is going to be du over u squared minus u plus 1. Okay, so now that I've split this up, I think we can do some integration here. So for the first one, this is actually just going to become 1/3 natural log of u plus 1. Okay, now for this integral, when I multiply -1/3 and -1/2, I'm going to have -1/6 out front. And then in this integral, we've set it up where we have t in the denominator and the whole numerator is dt. So we're looking at the integral of dt over t. I'm just going to do this in my head, and so when I integrate this, I'm just going to end up with natural log of t. But t is this thing, I'm going to plug this right back in, u squared minus u plus 1. And so in order to finish off this integral, we're just going to need to do this piece right here, which is 1/2 du u squared minus u plus 1. And at this point, that's when I realized that we actually have an integral within an integral within an integral within an integral within an integral. So actually, I'm kind of exaggerating, but we still have to solve this one integral. So I'm just going to take this off to the side, and we'll solve this one. So this is actually du over u squared minus u plus 1. And what I'm going to do here is I'm going to just complete the square on the denominator. So I can write this as u minus 1/2, just taking the half, just dividing by 2 on this middle coefficient here, -1. That's where I get my -1/2. So we have u minus 1/2 squared. If I multiply that out, I get u squared minus u plus 1/4. We have a plus 1 here. But if I add 3/4, we're fine. So we had 3/4 here, but what I actually want to do is I want to rewrite that. I'm going to write that 3/4 as square root of 3 over 2 squared. But for this one, I'm just going to use the arctan formula. Okay, so just taking this formula, putting it to use. Now, like, this is our variable. I'm not going to actually make the substitution because it doesn't really help us, but I'm just going to think of that like our x, and then our a value is going to be this piece right here. So we're going to have 1 over a, or the reciprocal of this is going to be just 2 over square root of 3, arctan, and then we're going to have this value, which is going to be u to the minus 1/2. Then again, we're going to have this 2 over square root of 3 value, so we're going to do it like this. But I can just distribute in this 2 and rewrite it. And this is going to give me 2u minus 1 over square root of 3. So let me just take this and we'll plug this in back here and continue. Okay, so that about does it for our integral of du over u cubed plus 1. The only thing I want to do here is notice when we distribute in the 1/2 out front here, this is going to cancel and we just have 1 over square root of 3. So what I want to do now is just take this whole thing that we just found here, and we're going to take this and we'll plug it back into what we found on the previous board and finish it off. Okay, now at this point we're almost there, but we just need to back substitute because we have everything in terms of u. We have our definition for u over here. And just to be clear, everything right here, this is what we just found for du over u cubed plus 1. That's just from the previous board. So it's a pretty long expression, so let's just back substitute now. So what we'll have here, we'll have 6 over 5, u to the 10th. We're plugging in x to the 12th, so we end up with x to the 10 over 12. I can reduce that to 5 over 6. Then we're going to have our minus 12 over 7. This is going to become x to the 7 over 12 here, plus 3, u to the 4th. So we're going to have x to the 1 over 12 to the 4th is going to give me x to the 1/3, minus 12, x to the 1 over 12. Then here I want to distribute in my 12, so this is going to give me plus 4, natural log of u plus 1. So that's going to be x 1 over 12 plus 1. Now just notice with an even power here, this has to be positive, so I'm going to just drop my absolute value and write that as parentheses. Then distributing 12 into minus 6, this is going to give me minus 2, natural log. Then u squared is going to be x to the 1 over 6 minus x to the 1 over 12 plus 1. But again, this actually has to be positive, so I'm dropping my absolute value because of the even root here with 6 and 12. That allows me to drop my absolute value. Then again, distributing my 12 in here, we're going to have 12 over square root of 3 arctan of 2 x to the 1/12 minus 1 square root of 3. And let's just put a plus c on the end, and that's it. So like you can see, we ended up with a really long answer, kind of a messy expression, kind of a messy integral actually, right? There's just like a lot of steps there, just a lot of work and kind of brute force. So we'll stop it there. Thanks everyone for watching. Have a great day.